All right, here's my attempt at number 2 on the 2024 stat exam. I've glanced through these but haven't read them in detail, so we'll see how it goes. A local elementary school decided to sell bottles printed with the school's logo as a fundraiser. Students at elementary school asked to sell bottles in 3 different sizes: small, medium, large. Relative frequency is the number of bottles sold for each size by the elementary school. 0.5 for small bottles, 0.3 for medium bottles, 0.2 for large bottles. Local middle school also decided to sell bottles as a fundraiser using the same 3 sizes: small, medium, large. Middle school students sold 3 times the number of bottles that the elementary sold. For the middle school students, the proportion of bottles sold was equal for all 3 sizes. Complete the segmented bar graphs representing relative frequencies of the number of bottles sold for each size by students at each school. So they said 0.5 for small bottles. And they said 0.3 for medium bottles and 0.2 for large bottles. So this one says the proportion of bottles sold was equal for all 3 sizes for the middle school. So that's about 1/3 for each one, the way I'm reading that. So it's going to be 33 1/3%, 66.6%, and so that's 76.6%. 66.6% would be here, wouldn't it? Those did not look equal, so. All right. That should be close enough. We didn't have to get out a ruler to measure it or anything, but 1/3, 1/3, 1/3, so we're going to put 0.33. Let's do 0.3 repeating. 0.3 repeating. 0.3 repeating. And we'll label this 0.5, 0.3, 0.2. Administrator at the elementary school concluded the elementary school students sold more small bottles than the middle school students did. Is the elementary school administrator's conclusion correct? Explain your response. No, because it said, well, let's check and see. All right.
I have a question. So why would the middle school have the same amount of things as the elementary school?
It says the proportion of bottles sold was equal for all 3 sizes. Not equal to the elementary school, equal proportion for all 3 sizes.
Oh, gosh dang, I messed up.
I have a feeling you won't be the only one who misread that like that, okay? But let's let E be the number of small bottles. Let's do E sub S. How about that? Number of small bottles sold by the elementary school. And M sub S be the number of small bottles sold by the middle school. And 0.5 times, oops. We may not have to go this far. They didn't give us a number. They didn't give us a number. All they said was they sold 3 times. So we're going to say no, cross it out. No, not necessarily. Let's go with this. Number of bottles, let's check it out. Number of bottles, so let's be by this elementary school. Is E. Number of bottles sold by middle school is M, and we know that M equals 3 times E. Yeah, we can't do this. And so the small bottles by the elementary school, E sub S, equals 0.5 times E, and the small bottles sold by the middle school is going to be M divided by 3. That's 1/3 of all the bottles. And that means that that equals 3 times M over 3, which is M. M equals 3E. And that's greater than 0.5E. And since 3E is the number sold by the middle school, let's see, that means MS, the number of small bottles sold by the middle school, is greater than the number of small bottles sold by the elementary school. Small bottles sold by the middle school is greater than the number of small bottles sold by elementary. When I first read that, Braden, that's what I thought too. I thought that they were equal, but then as I read it, I realized. 2 high schools also selling bottles, competing to see which one sold more large bottles. Mosaic plot for the distribution of number of bottles sold by each of the high schools is shown here. Remember, mosaic plot, the second dimension shows a greater quantity than the first dimension. The area is what's representing the quantity here. Which of the 2 high schools sold a greater proportion of large bottles? So high school A sold the largest proportion, .7, and B sold 0.6. Which of the 2 high schools sold a greater number of large bottles? I would say high school B because the area is greater. This appears to be about 3 times. I'll be back with you in just a minute. Let X be the number of bottles sold by high school A. The mosaic plot shows about 3x is the number sold by B. So let's do X sub L, X large, is the number of bottles large bottles sold by A is 0.7 times X. And let's go X. Let's go LA. How about that? Let's make this one LA. So this one is LB, the number of large bottles sold by B. Is 0.6 times 3x, when that equals 1.8 times x, and since 1.8 times x is greater than 0.7x, LB is greater than LA, so the number of large bottles sold by high school B is greater than the large bottle sold by A. Let's see. That was all for number 2.